Hello, this is me, Jake Clark, and this is me doing a video on unit circles and stuff. Again, apparently the first time I decided not to do the normal upload. So, first off, a little background on radians. For those of you that do not know radians, they started off as just pi, and I don't really know how they started out, to be honest. Pi equals 180 degrees, so that's sort of the conversion, just like how 2.54 centimeters is in an inch. I don't know how I remember that. Actually, I do. I just use them all the time. 2 pi, therefore, is 360 degrees. 90 degrees is pi over 2. 45 degrees is pi over 4. 22.5 degrees is pi over 8, even though you never really use that measure, sadly. But all this stuff, the most used degrees you'll ever see will be pi over 4, pi over 6, pi over 3, pi over 2, pi, 2 pi, and those are all based off of unit circles, not unit circles, special right triangles, which I might go over in another video. Um, first off, on, and then next up on what algebra 2 is based off of is sine, cosine, tangent, secant, cotangent, secant. All of those are trigonometric formulas, I believe, and they are very useful in doing all the identities. And the way sine is opposite over hypotenuse of an angle. So if I have a triangle, see how there's the angle there? Sine basically means that the value is opposite and of the opposite of the angle, the opposite line of the angle, and the hypotenuse. So opposite over hypotenuse equals sine theta. And cosine is the same thing, except it's adjacent over hypotenuse. So adjacent over hypotenuse is cosine theta. Those are the two identities that are necessary for finding the next four. For instance, tangent is sine over cosine. So tangent would be opposite over adjacent. Cotangent is the reciprocal identity of tangent, and you almost never really use it. But cotangent is cosine over sine. Secant is the reciprocal identity of cosine, so it's 1 over cosine. And cosecant is 1 over sine. If you want to use these things, you'll eventually learn all these special formulas, like the very useful one, sine squared theta plus cosine squared theta equals 1. That is such a useful thing. Never forget it, trust me. It will hurt you later. But whenever you're using a unit circle to draw an angle, a unit circle is basically a circle with an origin at 0, 0, and the side there is 1. So it's 1, 1, 1, 1. I'm doing this backwards. It's kind of great to do. So it's basically a circle of radius 1, the center at the origin. And the way you draw an angle is you start at the line where the origin goes to 1. So this is like the kind of the whole positive quadrant. And you start this line and you go outward. Oh crap, I'm doing this wrong. Go outward like that. So if you're going to draw a line, it will go, okay, I'm going to have to do this weird if I can't even do this. Curse being left-handed. You go like this. And it just goes around. It goes back to the 2 pi or 0 angle. And I know it's really confusing at first, but once you learn it, this is the single most useful thing you'll ever learn. Later on, you'll learn other things about the unit circle that are very useful, like where sine, cosine, and everything are negative or positive at. So if you want to do a coterminal angle, you'll have the terminal line, which is basically where the angle, that line where the angle just goes out. It's kind of like your jaw. You know how this part of your base doesn't actually move, but the jaw moves. What moves is the terminal side. The terminal angle is basically where its base is that terminal side. So it'll make another angle on top of it. And if you want to do a negative angle, you just do it backward, or you do it, hold on, backwards. There we go. How to get some coordination up in there. So that's pretty much unit circles and stuff. In a nutshell, my pronunciation of words is obviously very good at this time of night. Um, so that's pretty much it. If you have any questions, just ask, I guess.